Welcome everyone. I hope you must have got a good time to practice. Let us continue further. So this was a very simplest pattern of repeating whatever code that we had. As we said, let us try something extra. If you have seen, even if I'm not doing anything, this code is just running continuously. That is why you see this yellow border around. And also I'm trying to save some space here. The structure essentially looks like this. Okay, and let us see what all things we can do with it. So we create a block, and let's say repeat everything, and we give it an input, and we say steps. So repeat everything for these many steps, right? So how do we go about doing this? So we know one thing, like if we want to repeat something, then obviously we want repeat everything to be called somewhere again while defining it. But the structure essentially looks like this. Let's say if you want something to repeat 4 times, the way I will call it is I will say repeat everything 4, right? And so on. So that is basically what I want to do. So take a look at this structure. How do we know about the structure, or everything else we can consider later? But the basic structure goes like this. You define a block where you want to repeat something for a given number of steps, and then you put if then else block. In the if condition, what you need to do is you need to put a operator, right? What is the operator saying? If steps is equal to 0, then do nothing, right? That is essentially what we want. Otherwise, we want something to happen, and let us say that something to happen that we want something to happen that would be, let's say, move 100 steps and then turn right by 90, right? And after doing this, we want it to repeat. So take a look at this structure. We first define a block that says repeat everything, name it whatever you want. For now, just to make it understandable, I've said this. It takes a step. If the step value is 0, then it does nothing. Otherwise, it does what we want it to repeat. But then we need to call repeat everything again. And how do we do that? We say repeat everything, and then we need to give a value of the step. But as you see, it will start when the step value is beyond 4. But in order to stop it, we have to reduce it by 1 every time. So we use the operator, subtraction operator. And when we call the repeat everything again next time, we say we are reducing the value of step by 1. Right? And what would this draw me? Okay, I have not said pen down. So let me also say pen down. Let us quickly see what it is going to draw me. So I want my y to start with 0, and I'll say pen down. And it draws me a square. So essentially the logic that I have written here, if it is done 4 times, it will give me a square. So I can very well define square using this is the method. Right, so it can obviously take more inputs. Like for example, I want to draw a square of, let's say, why just 100, maybe 100, 110, etc. So I'll edit this. I'll probably give it another input. I'll call it maybe size. And instead of move 100 steps, I'll say move size steps. Right? So here I'll need to probably give size. I'll start with 100. Okay, what did I just do wrong? Okay, I didn't pass the size again. So I have to pass the size here also. It draws me a square. What will happen if I reduce the size? It will draw me a smaller square. If I increase the size, it will draw me a bigger square. And there you go. You can actually try repeating this here. Duplicate, maybe 100. And then I duplicate and say 50. There you go. Right? So I'm repeating whatever I want to do, but I'm doing it just 4 times. Even if I say 5 times, probably you won't see a difference, but you'll probably see the cat would be in this position. Take a look. It's basically just changed because it's doing one more extra step. So let me actually repeat this just to make it clear. So yeah, you will see it here. If I do it 6, it will do one more extra round. It will come here and so on. Right, but it will stop after doing those many steps. So it is currently stopping after doing 4 steps. So what is happening? First step, second step, third step, fourth step. That's it. Now we can actually do something quite interesting with this. We have taken a step and we have taken a size. And what we are doing here is we are moving those many steps ahead, the size which was given to me. We are moving by that many steps ahead, and we are also, if you see, turning by 90 degrees. What would happen if I divide my size, right? What will happen, let's say, if I take another parameter called as steps or sides. It has 4 sides, right? Square has 4 sides. So I'll probably take another parameter called sides. Right? What will happen if I divide my size that I'm giving here by the number of sides, as well as I divide the angle of 360, right? The entire rotation it does is of 360 degrees. 360 also by the number of sides. What will happen? What will I get? So let us quickly see what this leads to, right? So what I would do is I will say, instead of size here and here, what I will say is operators. Let us quickly put that. We need a division there. We here, and we also need it. So no, nowhere else we need that. Yeah, everything else is fine. So what we will do here is we will divide the size by the sides that we have. And similarly, okay, this same thing goes here, size, and we pass the same number of sides also. And we also divide the angle by the number of sides. 360 divided by number of sides. So take a look at this. It's exactly the same thing. We also take an additional parameter called as sides now. And now we are dividing the size by sides. And we are also dividing 360 by sides when we are turning. What would this give me? Let us quickly give it a try, right? Let us say my size is 100. The sides that I want is 4. I'll keep the size and the steps same, right? So steps is 4. I want something to happen 4 times, but the shape that I want is also of 4 sides, right? And size, let's say 150. What happens? Okay, let us increase the size, right? Let's make it bigger a bit, even bigger, maybe 500. Yeah, it gives me a square. So if I do something 4 times for 4 sides, it gives me a square. Now, this is interesting. Now I can actually draw a square of only 3 sides of it without the other side. So I'll just need to say do this 3 times, and that's exactly what I get. Right? But I can essentially do this 4, and I get my whole square back. But what I've essentially said is the number of sides that I want. What happens if I say 3 here and 3 here? That is 3 sides. I want it to do something 3 times for 3 sides. It gives me a triangle. What happens if I do 5 here and 5 here? It gives me a pentagon. What if I do 6 here and 6 here? It's a hexagon, right? Similarly, 8 here and 8 here. It gives me octagon, right? What happens if I continue to increase my sides? Let me say if I do 50 here and 50 here, draws me a circle. So essentially, it's still not fine. We can actually make this fine because essentially I want it to, like, for every angle, if every angle is my one step, then I should do 360 here, and then probably 360 here as well. Correct. So size, let it be 500, and you can see it's actually drawing me a circle there. Right, so we just got a circle back. What we know in case of this circle is this: if we try to measure what is the size of its edge, it will be 500. So if I need to draw a smaller circle, maybe 250, I just reduce this and would draw me this. I don't want this to happen this particular slow. It's just too slow, right? What I'll simply do is I'll edit this. I'll say run without screen refresh, and it draws that image for me in an instant. So let us try doing something interesting out over here. I'll duplicate this. I'll also duplicate this. Probably let's start with 500. Let's start with 250 here, and maybe we make 50 here, and let me hide the cat. There you go. A very, very interesting pattern. Looks like an eye. So I can sort of rotate its direction on both the sides, and I'll get something else altogether. So if it is looking in the right direction, if I'm getting this, probably let me try pointing it some another direction, maybe 180. What will I get if I say point in direction 180? So right down, that's 180, and do the same block again, right? The different pattern altogether, and I can keep moving this, like maybe I'll say not 180, but here, and it's on the other side, and I can actually make a block out of this, then again rotate that block, and I'll get a nice flower shape, right? So but that is up to you to try, but just give this a try. We just used a circle block. We used now this is how we can do a conditional repeat thing. We make use of this pattern, and we stop. So this is quite interesting. Try out various different patterns that you can do with this to make it more clearer. I can actually call it a pentagon, but this is not exactly looking like a pentagon to me. If I really want to draw a pentagon, for pentagon of, sorry, not pentagon, or polygon of any sides, I should somehow ensure that, but before you go that, I forgot about it completely. There's a significance of actually keeping this separate, right? So yes, I want 360 sides for the circle. Yes, I want it to be of size 500, but I just want to draw it half. How would I draw it? It's quite easy now, right? So instead of 360, I'll simply say 180 here, and I get a half circle. So you can give this a try. This can actually do a lot of interesting stuff. You can actually draw various shapes with it, and play around with it. Just use this time to play around. So yes, going back to keeping this 360 and making a full circle, essentially it becomes a pentagon if I can somehow ask the user, sorry, polygon, if I can somehow ask the user to just give the side number of sides that he wants and sides that he wants. Currently he needs to give 3 parameters. That's probably not a good way to tell somebody using this program. So what we'll do is we'll create another block, right? And we'll call it polygon, and it will take 2 inputs, sides and size, right? And what we do now is we say repeat everything here, sides and the steps, will make them as same, and we'll put the size here, right? So we put a polygon here, and we can now give it a try. We can say this is 500, but the sides that I want is just 3, and it will give me a triangle. If I now say 4, it gives me a square. If I now say 5, a pentagon. And similarly, if I now say 360, It gives me a circle. All right, that's one way to draw a circle. We'll definitely look probably in another way to draw a circle, but why don't you give this a try, practice it out, be comfortable with it, and we'll then again regroup and draw a circle in another way, right? So let's practice. Okay, welcome back, everyone. Let's do one thing, right? Let us quickly see something. I have just disabled the screen without refresh part, so it is actually drawing it, but the way it is drawing it is important. If you see, in this particular scenario, the cat is not at the center. How do I get a cat at the center? I want the cat to stay at the center and then draw the circle. Or the other way to ask this question is, how do I now move the cat to the center? Because it is very difficult. All we have is the outer border of the circle drawn. What is the center? So possibly the other way to do this is, why don't we now draw the circle from the center position? And what is unique about the center and the circle? The unique property of the circle is every point of a circle, every point that is there on the circle, from its center, every point is at the same distance. Right? So let's do something. Okay, we do definitely have a pen down to start with. Let me actually remove. I'll keep this as a polygon. Right? I'll keep this. I'll keep the polygon also with us for future reference. Right? Let me remove this. Everything looks fine. The unique property of the let me hide this also. Let's do this. Let's say this is the center. 0, 0 is the center. All right. Let us try doing something first. Let me keep the pen down out for now. From center, I want to draw a point, let's say at value 100. 100 is my radius. To draw that from the center position, I want my cat to move 100 steps. Right? And we all know how to do that, right? It's 100 steps here, move 100. So it will go by 100 steps. As if I click here, you will see it has gone by 100 steps. But then to be able to draw my next point, I have to again get him back towards the center. How will I get him back towards the center? Obviously, one way to do that is I can always say, go to 0, 0, and yes, it comes back to the position. But that may not be what I want to do. Like, for example, I might not want it to always start from 0, 0. I may want it to draw the circle from here, from this position. But what happens? Obviously, with the first step, let us try doing this one by one. With the first step, it will go 100 steps from there. So I can put a point there. But when it will try to go to 0, 0, it will actually not come back where it has started. So how do I get the cat back? And the idea behind there is, remember this, if 100 steps, moving 100 steps means taking it forward, then how do I get him back? It's obviously by saying the negative value of it. So minus 100 will get him back. Remember, negative simply means exact opposite. So if 100 means going forward, negative means coming backward. Right? Let's give this a try. Let's move the cat here. Moving 100 steps moves it forward. Moving minus 100 steps exactly gets him back where he has started. Let us try some other position here. Move 100 steps, move minus 100 steps, exactly where it has started. Let us do something else. Let us change its direction, right? Move 100 steps, move minus 100 steps, exactly where it has started. And this is exactly what we would use in our step. So let us first define what our step should be to draw a point, right? But all for our simplicity's sake, let us point in the direction, and while we are at it, let us start from 0, 0. We can obviously change this wherever we want later. So what we want to do, right? We want to go to the first step, that is 100 by 100. And after doing that, we want something else to happen. We want it to draw a dot there, right? So we'll say pen down. I'm currently not putting them in sequence. I want to do a pen down. So let's again start from 0, 0. What I want, how do I now draw that point at 100 radius from the center? Is I first need to go to those 100 steps. So I go to that 100 step, then I will say pen down, and then I will come back. But oh, there was a problem. It drew me a line. I don't want a line. So obviously, after saying pen down and putting the point, I also want to say pen up. Right? So let us give this sequence a try. And let us see whether that works. So move 100 steps, pen down, pen up, and move 100 step back. I'm not sure whether you can see it, but there is a dot there. Right? What I will do is I'll also try to increase maybe the pen size, set pen size to maybe I will say 10. Right? If I just click on this and do the same steps again, pen down, pen up, and now you see that there's a dot over there. So what do I need to do next? I need another point at a different angle for the same radius. So what I need to do then is I need to change its angle by that value. So what we will say now is rotate by, let's say, just 1 degree. Right? Rotate by 1 degree, move 100 steps, pen down, pen up, move 100 step back. We have another point there. Again, rotate by 1 degree, move 100 steps, pen down, pen up, move back. And if we keep doing this, we'll get our circle. Right? As you can see, it is already drawing the circle for us. And we are always drawing it from the center because we are getting the cat back. Let us put this whole thing in a loop that repeats how many times? We are doing one, we are all at all steps, we are changing it by 1 degree, right? How many degrees are there in a circle? 360. We need to do it 360 times and we will get our circle. So what I will do is probably I'll just give this for us to make a visibility of it. And this is exactly what should happen. Turn by 1 degree, pen down, move 100 steps, pen down, pen up, move back. Right? Let us put this in a sequence that repeats 360 times. So how do we do that? Remember, we just did put our structure. I'll call this as my circle. So circle, and remember the structure. We define a block. We take the steps parameter, steps as the input, number of steps, right? Okay. And I've just taken circle, defined this block called as a circle. It takes this particular steps. What is the other thing that we talked about? We go to control and we put if else condition. What do we do there? We check if steps is equal to 0, right? And when it is not, if it is 0, we don't do anything because that is the point we stop. If it is not equal to 0, then we put the whole thing that we decided to do earlier, and we call our circle block again here. And what should be the value of steps be? Right? The value of steps should be step minus 1. Exactly same structure as what we did for when we try to do pentagon. Sorry, polygon. Right? We just called it a repeat block. But this is exactly going to work it out for us. Let us give this a try. Let us go to blocks again. Let us move circle and let us say 360. We want this to happen 360 times. And there you go. It's drawing it for us from the center. As you can see, it's actually drawing it to us from the center. And I just got a circle. right? I can increase the size of my circle. Maybe what I can do is I can also take this step value that you see here as another input and call it radius, right? We can do that. Let us go here, let us add another input and let us say radius, right? And all we need to do is move first by radius amount. And how do we now say minus of radius? Well, one easiest way to do that is subtract from 0, right? 0 minus radius. So here we are going by radius amount and we are coming back. So if I say radius to be 50, it will draw me a very small circle. It might not be visible right there. But if I just hide this, yeah, it is there. It's a very small circle, right? Let us say the radius to something like 100. Did we do something wrong? We are turning. I didn't pass the radius again here because you added a new input. I need to move this here. Yes. So now it is doing for me at 100. Let it finish 100. Let us reduce the radius amount and let us see what happens. Yes. And it stopped after 360 steps. So let us say 50. And there you go. I would have two circles now, one smaller and one bigger. Exactly the way we wanted. Right. So let us quickly try putting this one after the other and let us see what happens. One of 50, one of 100. I'll stop this for now. I'll edit it and I'll say run without screen refresh. Right. And I'll hide the cat. What should happen? I get two circles. Right. Maybe I can draw one dot in between also and it will look like a bullseye. But this is how we draw a circle from the center, and I know exactly what the center point is. So what is interesting about this approach is this will work anywhere, right? Let me actually remove this, go to XY and move the cat here and it will draw it there. You can move the cat here and it will draw it there. And it will always draw it from the center. Right? The current position of the cat will always become its center position. But let us do something else, right? I'll first remove this part. Let us skip it to something like maybe 150. Let's make it a bigger circle there. And let's also do it from position center 0, 0. Right? So this is fine. I'll also take away the screen refresh. Right? So yes, but we know something, right? We know it's actually moving towards, it's actually going to each of these points and then it's also coming back, but we don't see it coming back. Right? We see it being here. We don't see it coming back. So why is that? And because it's happening so quickly, we don't actually visually see it. It's a visual trick, but it's actually coming back over there. But in a large portion, since it is moving at all the points, but center part is the one part where it is always going to be there, we generally see it staying at the center. So how do we do that? You know, if I wanted to really see at other points, how do I make it happen? Right? One way I can make it happen is let it move and let it do a pen up and pen down, but I'll wait after that. Let us see what happens if I put a wait there. So I wait here and let me say how long, 0.5, right? And you see it's already trying to do those points, but let me actually reduce it. Let's say 0.1. Right now, what you are basically saying is you're also saying it going back, right? Because of this this motion. So I don't want it to. What if I sort of reduce it even further, 0.01? So it's sort of flickering now. It appears as if it is going back and forth, right? So So that's fine actually. The other way that I can actually do here is instead of putting a weight, I can actually hide him, but show him only while he's at the border. Let us give that a try, whether that would work or not. So what I'll do is I'll remove the weight, let everything be there. Right? This is completely fine. I don't see the flickering right now. What I would do is I'll try to hide the cat first, always, basically hide the cat always, right? But show it only when he has actually moved there, then hide him again. So the way it would work is, let me go to looks, and I should get the option to show and hide. So I will say at the start, hide the cat. Right? So now there is no cat. But I will show it momentarily when it is actually at the edge, that is when it has moved towards the edge, and then I'll hide it again. Right? So what I will do is show, just like we have done pen down and pen up, right? I'll say show, and I'll also say hide. But probably it is, I think the other problem that is there is it's actually happening too rapidly. So now we need to give a weight. So let us give a weight between these points, and let us say something like 0.1. And now we see the cat is actually moving, right, from these points. If we just try to reduce it, 0, 1, the more we do it, the more better it will get. 0, 0, 1. And maybe I can try removing the pen up and pen down also. Then I should see it actually moving. Yep, as you can see, it's actually going around the circle, and this is looking pretty smooth. It's actually going around at center point in a very smooth way. Now why is this? Oh, and it just stopped, right? Now why is this significant? Like, it was always going back. But if you wanted to repeat, we all know what we want to do, right? We ignore the steps, we remove the if condition, and we just make everything happen consistently. Let us quickly do that. We just wanted to go round and round and round in the circle. We just saw how to draw a circle, but let us now just make him go around the circle, right? So I'll maybe change this and sort of name this go around the circle. Steps is not what I need. I just need radius. That is fine, right? I'll remove the entire if statement out. I don't need this, right? The steps is not required. I just wanted to turn, move, show, hide, and again move back and repeat this entire step. And this is how it would look like. It will continue to grow around, continue to go around this point. So let us see how this looks like. Yes, so as you can see, it will continue to go around this point. Now, why is this interesting? Right? Let us see what makes this interesting. Let me put a new sprite, maybe like this. So I have a new sprite, and I'll always put this new sprite at 0, 0. So it's there. Let me make it slightly bigger, maybe 150. It's slightly bigger. Instead of, I'll go to the cat sprite, I'll go to costumes, and I'll add a new costume to it. Right? So I'll say choose a costume, and maybe I'll say Earth. All right. Okay, it's a bit too big, 50. A little smaller. That might work, 20. Yeah. So we have a sun, we have a Earth, but the background is white. Like, that doesn't look like one. So, probably you must have got an idea of what I might be trying to do. What we'll do is I'll click on the stage, I'll go to the backdrop, and I'll paint the entire backdrop black. For that, I need a black color. That's exactly what I will do now. Paint the entire color black. So what would this give me? I go back to sprite 1, and I have Earth going around the sun. Right? The Earth is definitely not rotating around its point, but it is also it's rotating a bit, but its rotation is amounting to one entire movement around the sun. It could be a very interesting thing to do. How will you show this rotating around itself? Maybe that could be an activity. But we can talk about that once all of you are comfortable with what we have done. Now here is something interesting that we could do next, right? How do we put a, let's say, moon orbiting around the Earth? So if you remember, what is happening at every point here basically is we have this sprite. At every point for a given angle, we move it by the value given by the radius. We then show it, right? We wait for some time, we then hide it, we then get him back, and we repeat this whole cycle going around, right? So how do we now put a moon going around? But first, let me actually sort of maybe reduce the no, this is a bit too much, right? Let us say 110 or something like that. It's too close. Maybe I'll reduce the size of the sun then. Maybe 110 was a bit better size for us to see, right? How do I make moon go around this Earth? So one way that probably, let us approach this step by step, right? What if there was something at every point, another sprite at every point on the Earth, and since it's also having an angle, we always move the another sprite away from it by some amount, and probably that will sort of do the trick. So let us try doing that and see how things would work. And the way to do that, right, is let me try and duplicate this object, right, this sprite at every point, like whenever it has moved and when it shows, create a clone of it, right? Just make an exact duplicate of it. And what happens is in the control section, you will see this option, create clone of myself. So just when I show it, I say create a clone of myself. What will happen is I'll say a lot of this sprite object staying there. That's fine for now. We'll see how we solve that later, right? But that's basically the idea. I think we just created a lot of them, so which is fine for now. But we also need to destroy this clone sometime later. But let's do that one step at a time. Probably if you have seen, if I stop the program, all the clones go away, which is fine. But what should the clone do? What I want the clone to do is, as soon as the clone is formed, I want it to move slightly ahead. So what I will say is, when I start as a clone, move me forward by how much? Let's say another 50 steps or something. And maybe also this will sort of looks like this now, right? You can see that it's always there in front of it. Let me actually reduce the radius a bit, maybe 90, right? And you will see this is no, sorry, radius is good to be 100. So this is the Earth that is going around. Let's also increase the radius again, maybe 110. Yeah, you see what's happening here? This is the Earth that's going around, and these are the clones. We create a clone, we move it forward, and that's it. That's how it looks like. Okay, that's happening all the time. So what we want to do is, when I start as a clone, I move 50. Maybe 50 is not such a good idea. Maybe I'll say 20. So yeah, it starts pretty close. So what I can instead do is I can go to looks and reduce the size of my clone. Right? Please try all these things slowly. Go through this video one by one, pause it and give it a try. This might get confusing, but the more you try, the more you will get it. It's essentially a visual trick that we are trying to do. Okay. As my clone is moving 20 steps, I also want that clone to reduce the size. Moon is smaller, right? So I'll say set size by, so if this is 20, let us make it maybe half of that, so 10. sorry, minus, right? So if 10 is making it big, minus will make it small. So yes, it's already small. Let's also increase maybe this to 30. And yes, we can see it's going around now. But that doesn't look right? It's also leaving out the previous shapes in between. We don't want that to happen. What we actually want to happen is we want the clone to also get destroyed towards the end. So what we would do is we will go to control, and we will also say delete this clone after moving. But it's probably happening too rapidly. So what we would do is put a weight, just like what we have over here. Let us put weight before we delete it of 0.01, 0.001. Let's align it with this timing. And now we see basically everything is flickering. So there is a reason why it is flickering, because we are directly trying to delete the clone. What we should do is we should hide the clone first before deleting it. Right? So like this, hide and then delete it. So now you see it's actually going pretty smooth around it. But we also want it to rotate a bit faster, right? It doesn't look like it's going around the Earth. It looks like it's also making a separate orbit altogether. And that's also very easy to achieve. Over here, we will always rotate it by some more angle. So we would probably do something like this, rotate by maybe 50 degrees more, right? And you see it's actually going by some amount. But that's not exactly how we should be doing it. What we should actually do is we should actually take its current rotation angle, whatever that rotation is. We see direction, there is a direction, and we should probably multiply it by some amount. So what we should say, in point in the direction, instead of saying rotate by, we should say point in the direction of, let's use multiplication there, like this. Its current direction, that is what we will get from the motion. Its current direction. And if you want it to go faster, maybe something like 3. Let us quickly see how it looks like. Yeah, you can now see it's going around. If we make it more, maybe 5. Yeah, you see it's going around. And we can increase the quantity. Actually, we can also make it 10. It will go very fast. But now there is a problem. The moon doesn't look like a moon, right? So how do we make moon look like a moon? Is again, when I start as a clone, I need a new costume, right? Because it's the same sprite at the end of it. So I need a new costume. So let me quickly add a new costume. Do we have something like a moon? Okay, I don't have something like a moon. Maybe a ball I can use. Yeah, this looks fine. I'll probably try and use this. Okay. So what I'll need to tell in the code is I need to tell the clone to use, okay, let's name this as moon. Sorry, the baseball thing as moon. Okay. Let's go back and let's tell when I start as a clone, also change my costume. So that is in the look. Also switch my costume to moon. And there you go. We have a moon going around Earth, Earth going around Sun. We have just built an entire orbital system going around. You've probably seen this is just a simple logic. It's a visual trick. The sun sprite is doing nothing. There is no code over it. It may as well as be hidden. But essentially, Earth is the only sprite that exists. Moon is just a visual trick. Essentially, this entire rotation is a visual trick. And that's what we achieved. But we have built an entire orbital system out of it. It's just a visual trick. Right? Give this a try. This is how movies work. We see a lot of small frames at a smaller quickly enough, and our eyes don't see. Our eyes don't see them changing. We just see as if it is a continuous sequence, exactly the way we are doing it right now. It's a plain simple visual trick, but we have got some nice interesting effect out over this. Also, it makes me think, what if we ask the moon to draw something for us, right? So what shape would it draw? Let us quickly probably do something about it. Maybe at every point when it is there, when it is moved, we'll do a pen down and a pen up. So pen down, right, after it has moved, and then we'll also say pen up, and we'll probably say change pen color also. What would this do? It's drawing me a very interesting pattern out there. Right, there you go. I just have a pretty interesting shape. So maybe at one point of time, I think I can just hide the sprites, and I can have this pattern with me. So you can see, we'll go ahead, hide this, and have a very interesting pattern with me. Right. I hope you must have liked this part. I know if it sounds confusing, please take time. Please go through this video, pause yourself at every point, and give it a try. Right. We'll come back after some time, and we'll do one more interesting activity. Right. Do give yourself a time to practice, and we'll meet again. Thank you. Okay, welcome back, everyone. Let's look at the final step, right? We will quickly do something very interesting. So this essential structure that we just saw, right? We saw two ways of repeating things. One was this, and the other one was a structure like this that stops. This kind of structure is actually called as recursions. And what the recursions can do is very powerful, right? First of all, the idea of recursion comes from looking at a pattern and repeating the same pattern again and again. And not just that, we are also naming the pattern. So whoever is reading the code can really understand what's happening at every point in time. And you probably must have noticed that we try to do a lot of things without really having to create any separate variable over here. And we did a lot of interesting stuff. So yes, recursions are very powerful. And once you get the concept of blocks, you can use the same concept to repeat your code. You don't need to use any other structure to achieve the repetitions. But let us try something else. Let us try doing something else.